Okay, I'm teaching you today about 2.3.2. And since we have so many practice problems on the worksheet, I'm just going to go through and do some of those with you. And I had already started this problem when I realized, because a student told me, that I wasn't recording. So I'm going to start this one over again. But this root I know is positive 1 because it would make this part equal 0. So that's this dot right here goes with this one right there. Okay, next is x plus 2. That tells me x equals negative 2 because that would make this part 0. So that's this spot. And now this is going to be negative 3. There we go, negative 3. Put a dot right there. And that's that spot. So now I got all my roots. That means my graph must go through those dots. Next part. Do these have 1s or 2s or 3s as their powers? Do you remember that 1s are cut-throughs? 2s would be bounces. 3s would be a snake. Would look kind of like this. That's like x to the third, right? 3s are when they snake through. 2s are when they bounce like this. 1s are where they just go right through. That's a cut through. So that's worth 1. That's worth 2. And this kind is a triple root. It's worth 3. So back to these all have little 1s up here. Power of 1, power of 1, power of 1. And that means they're all cut throughs at those spots. So the graph might look something like that. But there's a few other things I should do before I make that determination of whether or not that's the right place to put that. So I'm going to just get rid of that for a second here. So it says be accurate with y-intercept. There's no number sticking out at the end here. So how do I find the y-intercept? Fill in this sentence for me. The y-intercept is where? What is 0? No, the y-intercept is where what? Not where y equals 0. The y-intercept is where what? X equals 0. I've told you this is very important. I told you it was important back then. It's important again. I'm going to say it one more time, and I want everybody to answer. The y-intercept is where what? X equals 0. Thank you. Okay, so if x equals 0, I'm going to put a 0 here, a 0 here, and a 0 here. And then I'm going to figure out what that y-intercept is. It's really easy if we just make this, and this all disappear. They're all zeros. So it's negative 2 times, sorry, negative 1 times 2, which makes negative 2. Negative 2 times 3, negative 6. Do you get how we just figured out that y is negative 6 is the y-intercept? Because we stuck in x equals 0. Okay, so negative 6, that means down here, that's the y-intercept. Okay, that tells me a lot about, you know, like where that loop in the graph has to go. It has to go through negative 6. So on this problem, it was negative 6. All right, and then end behavior. The end behavior is like whether it's going up or down on the right. Do you remember what that comes from? Yeah, is this, okay, first of all, what power is this? If I multiplied this all the way out, do you get it would be at x to the third? Okay, so it's odd. From yesterday, do you remember what odd ones do? Odd ones go in opposite directions. So since this has got an x to the third in it, that means one end's got to be up and one end's got to be down. Now, does it have to be that way? It might be the other way. Might be one end going down, one end going up. If you're not processing all of this, then you should be making notes off to the side, you know, in a notability doc saying that odd ones, they go opposite directions. And even ones, the ends go same direction. Okay, but anyway, this is an odd one because once we multiply that times that times that, we'll have an x to the third. So it's an odd one, and how do I tell whether it's down up or up down? That comes from the lead coefficient. If I had multiplied this all out, do you get my lead coefficient would have been a 1? Now, would it have been a positive 1 or a negative 1? Those are all positive, aren't they? So then the lead coefficient would be a positive 1. Since it's positive, if it's pos, means the right side is up. So I know it has to end going up. And since it's odd, remember it's x to the third, Since this is an odd one, they have to be going opposite directions. And if it's up on the right, it must be down on the left. So how do I finish this now? For this last part, you can be creative and just draw it so that the end is going down on this end. It has to cut through this and cut through that. It has to go through this point. It's kind of like connect the dots with a little more accuracy. And then it's be going up on the right. There. Now does it break any of the rules that I know? Well, it's going through the right y-intercept. It's going in opposite directions on the ends. That's good because this is an odd function. The right-hand side's going up, which is good because it's positive in the front. This lead coefficient, if I multiplied it all the way out, that would be a positive 1. Okay. Now this one's got a twist in it I want to show you. When you're doing this one of these things is not like the other. Yes? The 4 minus x. I better rearrange that. Do I just say x minus 4? No, that's different. Negative x plus 4. Why? Because now, do you get when I multiply the front numbers that my lead coefficient is going to be 2x, negative, and a positive 1, so it's going to be negative 2 is my lead coefficient. Okay, what happened there? This, this, and this tell me that it's degree 3, because I multiply them all together, I'll get degree 3, and that there'll be a negative. That one right there has a negative, so it's going to be a negative. So I know it's an odd function, and its lead is negative, which tells me it's down on the right. All right. Now I'm going to take just a second to go off reservation, so to speak. I go over here and say, if I gave you this, you need to be able to say, flyover country, what do you know about this equation? I want you to make a quick sketch of what this would have to kind of look like. Just reminding you what we taught you yesterday about what does this mean, what does this mean, and what does that mean. Make me a quick sketch, and I'll tell you either yes, yours could work, or no, it couldn't. I'm going to turn it my way. Can't just sit there. I'm going to pause. I saw lots of different options. Some kids made it as simple as this. That's fine. The parabola that's going down. Why? Because it has to be right hand is going down. That's what tells me this. This part tells me both ends go the same. So if their one is down, the other one must be down. And then this tells me it has to go through 8. So this is a totally good graph. But so was this graph a different kid made. Like that. That's okay, isn't it? Still going down on the right. Still have both of them going the same direction. And you still have a y-intercept of like 8. So the point is there's multiple options for how these work, but they have to follow these 3 things. That means the right side's down. That means that they're both going the same direction on the ends. And that tells me the y-intercept. All right. So when we've got them like this, you've got to be able to say, what's the lead coefficient? You know, that number in the front? You know how I was saying this number is so important in the front? And the flyover country doesn't really matter? And then the plus 6 or whatever at the end is important? We got to know how to get those from this. So how do we get this part? From multiplying this and this and this all together. That's going to make negative x to the third. See what I did there? The x times the x times the x made x to the third, and then one of them is negative. Negative x to the third. Then how did I get this last number? That's the y-intercept. So the y-intercept is where what? Say it. X equals 0. I make this 0, and this 0, and this 0, and then I multiply it all out. 3 times 2 makes 6, times that's negative 0. That's just 0. 6 times negative 3 would be negative 18. So there's my last number, negative 18. That tells me the y-intercept is negative 18. Getting the idea? Okay, now let's go back to the worksheet again. Pause for a second. Okay, I found it. I'm going to clear this off and move down and show you a different kind of problem. By the way, there's enough on here that I can probably skip a few. I'll let you skip number 4. Okay, this is continued. Sketch the graph by hand, be accurate. Basically, it's the same exact thing. So basically, there's a whole lot of problems like this. I feel like you don't need this many, but it's just, this is a little different because it's got a squared in it. That's kind of important. So I want you to do that one, and I want you to do this one. So 5 and 6 are good. I'll have you skip 7, lucky 7. You can skip that guy. It looks really long and scary, but remember, only the front and the end really matter. That's flyover country. Okay. So here, these are in factored form. Let's do number 5 together. Do you get that the root there is positive 2? So I'm going to go over to 2, put a dot there. That's one of my roots. The root here is negative 1. Put a dot there. And the root here, positive 3. Putting a dot there. Now, lead coefficient. If I were to multiply out this and this and this, something's wrong this time. Does anybody know what's different now? There's a squared. So it's like this is x squared times x times x. Means the lead coefficient would be x to the 4th. Do you get that it would be positive? Because all those numbers are positive. Okay, so it's positive x to the 4th. So all we need to know is the end number then. You know, flyover country, doesn't matter. And then at the end, that last number comes from, the y-intercept is where what? X equals 0. 0 here, 0 here, 0 here. Negative 2 squared is 4. 4 times 1 is 4. 4 times negative 3, negative 12. So there's the important parts of my equation. The beginning and the end. So now I know this thing is positive in the front, so it must be going up on the right. I know, ooh, this is a good one. See that squared there? That means it bounces at the 2. So I know there must be a bounce. So if I go through this, there must be a bounce there. And then it has to go through this. And what degree is this? To the 4th. So they have to go the same direction. It must be going up on this side too. So I got to finish this by going like that. All right. I think you're good to go for up through number 12. I'm going to pause for a second and let you work in that section. So I'm back to give you some more help. Let's move down further in the sheet. Up through 12, they're all the same. This limit notation thing I want to cover with you today. We didn't really talk much about that at all yesterday. So let's all do this one together. Please get to number 13 right now. This is an important skill. All right, first thing we got to do is sketch. We got to make a quick sketch. The practicing we've had of making these sketches is probably going to help. Notice I don't know exactly where the roots are on this because it's not factored. We're not going to expect you to go through and factor something really complicated. So we don't care exactly where you put the roots then. What do we care about? Do you think I care that the right end is down? Yeah, because it's got that lead coefficient negative. Right end better be down. Now how about this? Since it's an odd degree, do you know about the left end then? Left end's got to be up. Now, do I really care exactly how you draw this? Nope. Say it's like that. Basically, one end's up, the other end's down. The right-hand side has to be down because of that lead coefficient negative. Oh, wait, one more thing. I broke a rule. What's that? That's the y-intercept. The y-intercept is supposed to be what? 3, so I better be careful on that. All right, so now I'm going to make it one last little quick sketch that's got a y-intercept of 3. And then is up on this side and down on that side. There, that works. It's up on the one side, down on the other. It's going through 3. This one would have one real root and 2 imaginary roots. Okay. Now, could I have made it bounce off of here and then I'd have three real roots? One for this and two for that? Yeah, that'd have been okay. All right, so once you have your sketch, this is the part that you don't know yet. You don't know how to do limit notation. So let me show you. You need to write this down. Limit notation has to be written exactly this way. The lim for limit of the function, lim f of x, has x underneath the limit. You have to put the x underneath the lim. Like the calc teachers tell us that when they grade these things on the AP Calc test, if you have your x arrow in the wrong spot, it's wrong. They don't give you the credit. If you move it over, like put it over here, x goes to whatever underneath the f of x. Nope. It has to be exactly this way. Really picky. Now, then put an equal sign here. Now here's the part that you have to actually fill in. See, that's how every limit will look every single time. You're going to always write that framework. Okay, lim of the function as x approaches. Now what I need here, I'm not putting anything yet, is an x value. What I need here is the y value when it gets there. Let me explain what I mean. I need two numbers. One goes here, one goes here. And that's the part you'll have to figure out for each problem. Okay? Now, if they want the end behavior, do you get the ends of this function are way out that way and then way over this way? Those are the two ends. There's the left end and the right end. Okay? Then I can make you an even more specific thing that every time you ever do the limit, if you want the left end limit, it'll always be as x is approaching. Anybody want to take a guess at this? Negative infinity. Very good. Why? Because x's run this way, right? Or this way. And if I'm on the left end, I'm on this end. So x is going to approach negative infinity. This is how every left end limit should look. And then the only thing left is you have to figure out what y has to equal. Now, before we even finish, I'd like to do the right end limit, because I bet you can get it. It's exactly the same as what I just circled there. Everybody write this underneath. Right end is going to be lim f of x is equal to, and x has to be underneath the lim. X approaches. Now, if it's on the right end, x isn't going to approach negative infinity. X is going to approach what? Positive infinity. Okay. And again, I still need an answer. It goes right here. But every right end limit you ever write for the rest of your life, I shouldn't say that because if you go to college, there may be some weird exceptions to this. But here, every right end limit has to look like that. Limit of the function as x approaches infinity is the right end. The left end is as x approaches negative infinity. It's the only difference. Now I need an actual answer. These are really easy. Once you've got all of this other part, it's really easy. If I go to the left end of my function, if I go way to the left, what's the y value going to go to? Remember, we're talking extremes here. If I go forever to the left, what's my y value going to go to? That's this part right here. What's that headed towards? Positive infinity. So this will depend on each problem that you do. That's always the thing you'll have to figure out. But if you ever are doing a left end, all of the other stuff stays the same. All of that I have up there is perfect. And I just have to figure it out. On the left end, where's it going? It's going to positive infinity. On the right end, where's it going? That's the right end of the graph here. If I go way to the right, way this way, then what is the y value going to be? Way down there, negative infinity. That's writing the end behavior with limit notation. Okay, I did that very slowly because you're just learning it for the first time. But whenever you see, oh, limits, if you can just snap off this part of the formula right here, Even if you don't know the answer, if you know the left end and the right end, all you have to do is figure out one thing, like infinity. That's it. They're such easy questions. They're just scary because they have this notation that you have to memorize. All right. So now, on this next one, number 14, again, if you're going to do a left end limit, you can just write it ahead of time. Lim of the function as x approaches, and now the left end of the graph is the way over there, so that's x approaching what? Negative infinity equals, it's there. It's all ready to go. All I have to do, it's supposed to be an m there, sorry, is figure out what it is when it gets there. So don't I need a sketch for that? Because I don't know if my function's going up on this side or if it's going down on that side. We have to figure out where it is on the left side. So you make a sketch of it. That's the part you have to, that's actually a little bit of a challenge. You know, it's an x to the third, so the ends are going opposite directions. You know its right-hand side there is down, sorry, up, because it's positive in the front. The right side's going up, and you know it goes through 7 as a y-intercept. Flyover country. Okay, so you can make your sketch really easy. Then your left end limit I started for you. The right end limit is just where x approaches positive infinity. Yes?
Wouldn't that be the x to the third?
Oh, did you catch me making a mistake? How dare you? That is the lead coefficient. Sneaky, sneaky. Because it's got the biggest power. So this is actually part of flyover country. Thank you for catching that. Save some people some pain at home tonight. And they're like, what's wrong with the key? That's the lead coefficient, and that's the y-intercept. That tells you your graph might have to look different than you thought, because its lead coefficient is negative. Thanks for catching that. Okay, so let me clear this. I've taught you a lot of stuff today. I hope you've been able to process it. Here's some just easy, quick reminders. There's a few too many of these. I'm fine with you skipping number 18 on this one. Find the zeros algebraically. What does that mean? The zeros. There's 4 names for those. Zeros, x-intercepts, what else? Roots, what else? Solutions, or solve. Okay? And that always means factor it if you can, because that's the easy way. But if factoring doesn't work, what always works on quadratics? Quadratic formula. Quadratic formula always works. So if you want to find the zeros, try to factor it. Factoring isn't working for you. And sometimes when it's just hard to factor, you're like, heck with it. I'm just going to use the quadratic formula right away because factoring is so hard. And it's fine. You don't. It doesn't say you have to use the factoring. So I'm going to do quadratic formula right away. X equals negative b, 3. Plus or minus square root b squared, which is 9. Minus 4ac, 4 times 9 times negative 2. That's where everybody messes up, right in there. Be careful because there's 2 negatives. It's actually going to be plus all over 2a. 2 times 9, 18. And I betcha when you're done that this will simplify down. So it won't be some weird root. It'll probably be a root that can simplify. All right, we've practiced that enough on the top 20. If you've taken the time to learn that, now you get the payoff. Okay, this one, a lot of people go, okay, say, fine, server, you like the quadratic formula so much. Why? I can't do that with the quadratic formula because it's cubed. True. So that means it must do what? Can't use the quadratic formula. You better go back to what? Factoring. Get out something factors out of this. X factors out of that. And then what do I have left? X squared minus 25. And then you can factor that. Okay. Let's slide down here. This is all the review stuff, so I don't want to spend any more time on the video talking about the review. So that's all I've got for you for today. I taught you a lot of stuff. We aren't going to be tested on this until next Monday and Tuesday. So we have several days here to get this all down. Get your homework done tonight, though. Yes, sir.
Wait, so one's the calculator test, only for the one.
Good question. I'll tell you that after the video.